Hi there, good day. So, there's another topic that we are going to discuss this time. It has a relationship with what energy is. So, therefore, we need to identify kinetic energy and we have to calculate for the kinetic energy. So, remember that in energy, if we're going to define it, it's the ability to do work. It has something to do with um, power and then energy as what we have had discussed. So this time we're going to focus on the first type of energy, and that is kinetic energy. We can also call this one as mechanical energy. So we can define it with the same thing what energy is: capacity to do work. The greater the energy of a body, the greater is its capacity to perform work. So, if you have a lot of energy in your body or the body of the object, then there is a greater opportunity to perform the work. So, this means that whenever work is done in an object, it gains enough energy. And of course, if 1 Newton meter of work is done, the object gains Newton meter of energy. So they're equal with each other. So in kinetic energy, it is the energy if the object is in motion. So where it be a vertical or horizontal in motion, then it has kinetic energy. So remember, it is the energy if the object is in motion. So we have the different types for this kinetic energy. It may be vibrational kinetic energy, a rotational kinetic energy, and the translational kinetic energy. So with that three, we're going to focus on the translational kinetic energy. So in translational kinetic energy, it is the energy to the motion of the object from one location to another. So the object moves from starting point going to the end point. So the amount of translational kinetic energy depends on two factors or variables. Number one is the mass of the object and its velocity. So then again, it's all about the mass of the object and the velocity or how fast it travels. So therefore, if we're going to calculate for this, kinetic energy is equals to 0.5 times the mass times squared velocity. So we're in kinetic energy is the unit for that is in joules. Then for the mass, representing small letter m, that is in kilograms, and velocity that's in meter per second. So how are we going to calculate this? So in translational kinetic energy, since the mass is never negative and the squared velocity will always yield a positive result, then the body's kinetic energy has only two possible values. It may be 0 and positive, so there will be no negative. Kinetic energy becomes 0 when the object is not moving. So remember that. The object is not moving, then the kinetic energy is 0. And positive when the object is moving. So if you're going to use the equation, then you must understand the following points. That kinetic energy is directly proportional to the mass. So the greater the mass, the greater the kinetic energy because they are directly proportional. Then when it comes to the speed or the velocity, kinetic energy is also directly proportional to the square of its speed or what known as squared velocity. And remember, there's no particular direction given when it comes to kinetic energies. Therefore, it's a scalar. So let us calculate this kinetic energy. Let's say there is a 10 kilogram object moving with the speed of 5 meters per second. So how are we going to get the kinetic energy? Following the given formula to find kinetic energy, let's find out the first or the given in the word problem. And for the mass, we have 10 kilograms and the velocity is 5 meters per second. So to find kinetic energy, we have to multiply 0.5 times 10 and its squared velocity of 5. If you're going to calculate that, then we might have, we should square or multiply by itself the velocity, you get 25 there. Then you can multiply it in the mass of the object and finally the 0. And that will give you 125 joules. So I hope you learned something about what kinetic energy is and how are we going to calculate for this. See you next time on the next review. Thank you very much for listening and watching. Bye bye.